Alright, systems of equations. So a system of equations is typically coming in a pair like this one, and they can come in more than a pair. They can be three or four or five, and what you do is solve them. And the reason you solve them is because this x and this x are equal to the same, and this y are the same, and so you have to find the solution for x and y that gives you the value that you want, or not the value that you want, the value that you've been given. And you can solve these in three ways. And I'm not going to go too in depth into them, but elimination, you add these two equations together like you would in a regular addition problem. And you can multiply this equation and this equation by two different coefficients so that one of the variables, the x or the y, cancel out. So then you're given an x or a y is equal to a number. And there's some special rules that go along with that. And then there's substitution, where you solve for one variable like, say, x here. So then you have x is equal to some value plus or minus y, and then you plug that in, you substitute that value for x into this equation so that you only have one variable, in this case it'd be y. So you'd have a times some value plus or minus y plus some value b, which is equal to some number c. And then you can solve for the exact numerical value of y, and then go back into this equation with your substituted x is equal to something y, and solve for the value of x. And your third solution is the graph, where you turn this into a y is equal to equation, turn this into a y is equal to equation, and then you find the point at which this graph intersects this graph. And that gives you the solution in x and y that have to be true of this equation to get the numbers that c and f represent. All right, enough jibber jabbering. Do we want to make this into a program? And should we make it into a program? Well, we want to, because it takes time to do this calculation each and every time, and that's something we're going to repeat. So it would save our time in the long run, because it's something we're investing our time in now, and then we have less time that we have to waste later. And it's something that would actually be complicated enough to actually program, as we talked about in our last video. So here's the gist of it. But how I got here, I probably should have set that up first. You take the same equation that you had here, same pair of equations, and what you do is you just solve it with any of the methods, preferably elimination or substitution. Graphing is really isn't going to help you. And then you get this. I forget exactly which one this one is. I think this is substitution. No, this is elimination. So you say, okay, well, you have d, because you're going to have some number d. So let's say we're doing substitution. So dx plus ey is equal to f, right? So we have to get something x is equal to something y, right? So we're going to subtract ey from both sides and subtract it from here, and then divide both sides by d. Right? And so then you get x is equal to f minus ey divided by d. So we did the same thing with substitution. We copy this, and actually, first off, we'll copy this, paste this, and then we'll take this and replace x. Actually, no, I have to do the other one. Whoops. Almost made a mistake there. Alright. You copy this, you replace it with x. And then you solve this equation for y is equal to. So then you would, when it's all written out like this, it's kind of hard to read. But you should be able to do AF minus AE, get rid of this A, and then divide everything in here by D. Oh wait, no, got this wrong. Whoops, got this wrong. I did this wrong. That's funny. So you divide both sides by A. Yeah, that's why pen and paper is nice. Anyway, you do this all, now you'd follow that process all the way down, and then you would get your output. And then you double check that. You always got to double check it. Make sure you double check it. So you find some problem, you solve it the regular way, and then you solve it just putting in the numbers to this equation. Bada bing, bada boom. If you get the right number, keep testing it, keep checking it, and if it does work, you'll be able to, we'll need that, say definitively that your method works. But that's how you would get from here to here. Okay, great. So we have our 6 variables. Well, if we're actually writing the program, we'll delete this. You have to get your input, right? input, calc, and output, just like we had last video. Sweet. So we need to prompt, which is a different equation, different command than we used last week. Last week's or last videos, it was what was it? Input. That's right. Input is different because you have some text in front of it, but with prompt, it's just going to ask you what the value is. It's not going to make anything fancy out of it. So you'll just do A, B, C, D, E, F. And before this, you actually probably want to display the format, because if you have Y in the first variable or X in the first variable, that difference is probably going to throw you off, unless you have X and Y in the same places for both equations. But even then, if you're going to have X is equal to here, it's going to be backwards. So you're going to say form is equal to AX plus BY is equal to C. And now when you're reading this, or when you run this program, it'll show this, and then it'll ask you for your values. And then you would say display here X is equal to, comma, that, and then you can just do parentheses, or quotes, comma, go here, comma, and bada bing, bada boom. If you want to double check your work, I guess, or do it a different method, then you could also derive the second equation, because this is, I forget what method this is, but it really shouldn't matter because they should both give you the same output. The only reason you have different methods is because it's easier, depending on the numbers that you've been given, to do it by hand a certain way. So there's that. If you want to graph, there's another way you could do that. You can actually find the graphing solution if you need to do that. There is some manual input you have to do, but you can do the exact same derivation of it. So all you have to do is just take the AX plus BY is equal to C, and then you would just solve for Y. So you get minus AX, and then you divide this by B. And then you'd have Y here. And then you would put this into the Y function, and there's a way you can do that just by using this command, which is the store function. It'll be on the bottom left. And then you go here, this will be Y1. So get rid of this. So this command right here will save this C minus AX divided by B in the Y1 function. So when you go to the graph, or when you go to the Y is equal to button on your calculator, it'll show you this equation exactly. It won't show you the numbers, but if you did this command correctly, then it'll give you that. It'll have the same value. It just won't show it. Then from here, you'd have to do the Y2 equation. So you'd also have the Y2. And then you'd have to click some buttons. So either you could display, click these buttons, or something to that effect. And then you'd have to list the buttons, because there really isn't any way to run the command, because effectively what you're doing is just running the math, which is what the intersection is doing. So, but if you want to know what the numbers are, I believe it's second 5, which I think is intersect, and then hit enter 3 times. And that'll say which was the 3 enters is one of them selects the first equation, the second one selects the second equation, and then the third one asks if you want to guess where the intersection is going to be. I don't really know why, but it does. And then it doesn't really matter. You don't have to put a guess in. You just hit enter, and then it'll give you the exact equation, and the exact solution. So you'd have to display or know what buttons you have to press if you want to do the graphing route. So that's how you would do that. Quick review. So you have your systems of equations, which are 2 or more equations where the same variables are the same things, so that the y and the x are the same value. You have your 3 different methods: elimination, substitution, and graphing. But from a programming perspective, these 2 are your only viable options, and they're both equal to each other because they both give you the same output. The only reason that you would choose one over the other if you're doing it by hand is in case you have one of them would be easier. So if you get fractions using one method, you can use the other, and you shouldn't really get fractions, or it should be a little easier. But if it's telling the computer to do it, then the computer doesn't matter. It's still going to give you your 1 or your 2 or your negative 56. Just make sure that if you're going to be deriving these equations, that you double and triple check them to make sure that they are correct. And syntax. Cannot stress that enough when you're doing these things. Make sure that your syntax is correct. If it's not, then it'll throw you an error, and you'll be able to say exactly where your syntax error is. but if you double triple check to make sure you copied it over correctly and then you're getting an error, I mean, it's a little scarier, but at least you know that it probably isn't your syntax, it might be your derivation. So you can delete this. We have our three lines, and actually you should be able to, now that I think about it, take the display, take whatever this line is, and then make it your input for A. The downside is you're still going to need an input for B, C, D, E, and F. So if you want to write that out and make it your 2 lines, you can. But anyway, this is your system of equation. So now you got to have your title. You can have eight characters that you can use for your title of your program. They're all going to be capitalized when you put it in your program. So don't, lowercase doesn't matter. That being said, good luck, and see you guys next one. Don't forget to like and subscribe at the bottom, and good luck.